In this video, we'll work with actions and reducer capabilities for the cart component. We'll write complex state mutation logic that allows us to simultaneously mutate multiple state properties. Let's begin. The cart component basically lists a summary of products in a collection with quantities and computed total costs. But there's a lot more to it than meets the eye. On the catalog page, we first need a way to add products to a cart. And if a product already exists, we must not add it again, but should increment its quantity in the cart. Second, on the cart page itself, we should be able to update the quantity of an item or remove it from the list. Updating the quantity should recompute the total number of products in the cart as well as the total cost of the cart. Finally, we should be able to remove the item from the cart, which should again lead to recomputation of the total cost and the number of products. This means we are looking at three actions and their respective reducer capabilities. The add to cart action should add an object describing the product to an array called items in the cart. If the product already exists, the quantity value should be incremented every time the action is dispatched. The set quantity action should include the product code and a number, and it should not only set the quantity of the product in the items array, but should also recompute the total cost and total products values. The remove item should remove the product from the items array and should recompute the total cost and total product values again. So let's start working on these right away. Once again, you can choose to continue working with the outcome of the last video, or you can download the project for this video from the link given on the screen. Let's begin by creating our three action creators for the cart. I'll create a new file named cartactions.js in the actions folder. First up, we have the add to cart function, which accepts an object describing the product and returns an action where the type is add_to_cart and the product object. Next is the set quantity action creator, which takes the product code and quantity and returns an action payload with the type set as set_quantity and the code and quantity values as the payload of the action. Last, we have the remove item action creator, which returns an action with the type remove_item along with the product code. Okay, let's get back to our cart reducer.js file and we'll use the switch statement, and before building any case, let's set the default case to return back the state as is. For the first case, add to cart, I'll use a ternary expression where we'll use state.items.find to first look up the product that we are attempting to add to the cart. If this item exists, we'll increment its quantity, or else we'll add it to the items array among other things. So first up, if the item does not already exist in the items array, we'll increment the total products count by 1. We'll then add the cost of the incoming product to the total cost value. And for the items array, we'll first ensure we have all existing items from the cart using the spread operator. And then we'll add our product as an object where I'm going to add a property called quantity and set it to 1. Now, if the product already exists in the items array, then once again, we'll increment the total products value by 1 and we'll add the product cost to total cost. But for the items array, we'll use the map method to find the product by its code, and if found, we'll increment its quantity by 1. This is how we can add a product to the cart and add more numbers of an existing product. Next up, we have the set quantity action. Here, we'll first use the map method on the items array from the state, and we'll set the quantity as received from the action payload. Since updating the quantity of a product will have implications on the total product and the total cost values, we'll recompute them as well. Using the updated version of the items array, we'll recompute the total quantity of the products using array.reduce. Similarly, we'll recompute the total cost of the cart once again by using the array.reduce function. We can then return our state setting the values as recomputed here. For the remove item case, we'll first find the desired item in the items array. If found, we'll find out the cost of the item as per the quantity held. We'll then return the state object where we'll subtract the quantity of the item held from the total product's value, followed by subtracting the total cost of item from the total cost of the cart, and finally for the items array, we'll use filter to remove the items listing. This was a bit more complex than the catalog reducer. However, you can see multiple state properties can be computed at once, unlike set state or the use state methods in React components, which are asynchronous by design. Since a reducer is a pure function which takes the current version of the state and returns a new and modified version, composite state mutations are a breeze. Alright, our app's logic is now done and ready. Last time we used the connect higher order function. In the next video, we'll use Redux hooks to connect the cart component to the store.